SwiftUI Swipe Actions from Scratch, Part 1. Hello there. Today we're going to look at doing swipe actions like this. This is the default swipe action, and it's pretty easy to implement. But it has a few limitations. One, you can only use it in list views, which this is a list view. And there's even a weird bug in it, which is once I expand the actions and then put my finger on, move it a little to the right, it actually triggers the default action for a moment. Their thresholds for triggering that are a little weird. It turns out the expansion state is slightly beyond the triggering state, so that's not ideal. And it's just very limited. You have to use it in lists. So we're going to build our own from scratch. And there are some tutorials already on the internet for this, but I haven't found any that go as far as I would like or touch on some, I don't know, just pet peeves that I have. So this is a custom version that we can start with. And it, it looks pretty similar. There's some easings that I don't love with the animation, but it works well enough. However, and you can't see me do this, but I'm swiping left and right fairly hard now, forcefully. And now I'm doing it very gently. But it all sort of looks the same. There's no velocity taken into account in this animation, which is, I don't know, it's just not how most SwiftUI views work, or most iOS interactions work, the nice built-in ones at least. Even this one, despite its limitations, has velocity. So if I swipe gently, soft, easy. If I swipe around forcefully, it shoots here and there. It overshoots its target and bounces back. So we're going to work up to building this, which is similar. However, we'll see that it has some velocity taken into account. And if I swipe beyond the threshold, it triggers the action. Or I can just tap on one of these actions. And there's some visualization here, which is basically the point at which the expansion will be enabled if I were to release, or there we go, for it to close. So I have to cross this red line for it to expand outwards. However, with inertia, I don't quite have to reach that red line. It'll figure out the intended end state based on how fast we're swiping. And then if I cross this blue line, that will trigger this default action. So, nice stuff. And with this fully custom view, we can also, have no background, like the plain list style, or we can have some crazy thing and just put it in whatever shape we desire. So a lot more flexibility. We don't have to use it in lists. We can use it elsewhere. And we can also, just have more control, which is maybe not worth it all the time because it's more work than just using the built-in one. But if you're really fickle and persnickety and have high standards and your perfectionism is a constant splinter in your side, well, then I have a solution for you, hopefully. And let us just first warm up with the normal built-in list swipe action. So I will start by making a list. I'll throw some text in here that says, hello, I am normal list item. Then we'll say swipe actions, open up the trailing closure, and throw some buttons in here. So they'll have an action, which I will just say print default. And then I will make an image label here. It's very ugly. System name, let's go with sparkles, and we'll give this button a tint of blue. And there's our list item. We can swipe. It opens. If I click and open up the console, default has been printed. And if I swipe it all the way and release, default also triggers. So that's wonderful. I can add a second action here by copying this, pasting it, saying trash. Let's say trash.fill, and let's make it red, not blue, red, re-rendering. And there we go, we have a trash as well. So the default action is going to be the first one you listed in this closure. And if I click on trash, though, it says trash. So pretty easy, and there's some other options that we could look at. But for now, we're going to ignore that. Built-in swipe actions couldn't be simpler. However, if I were to change this to instead be, let's say, a V-stack, if I get rid of the list, no more swiping. Even if I throw the V-stack in a scroll view, no swipes. So that's unfortunate. It has to be in a list view, which sometimes you want to do fancier things. Use grids, use V-stacks. There sometimes, list can be annoying and fidgety now and again. But if you want to get those swipe actions, you have to use it. So let's instead do a lot of work and break out of the box and re-implement it ourselves. So before we embark on our custom implementation, let's just briefly review some notes. So we will begin with some views like this. We're only going to be worrying about a single one of them, but eventually we'll probably have multiple views, each being one of these swipe views, swipeable views, whatever we wish to designate them. And then at some point, the user will initiate a drag to the left. Let's say the user has dragged 60 pixels to the left. At this point, we will offset the initial text view by 60 pixels. And in that gap which is opened, we will start to slide in some of our swipe actions, and they will each be allocated a segment of those 60 pixels. So if we have 3 swipe actions, they will each be given 60 over 3 pixels, so 20 pixels apiece, etc. And then eventually, if the user were to release beyond a certain point, we would expand all of these swipe actions to their full width and sort of hold them here until the user swiped them away or continue to swipe to the right, or sorry, continue to swipe to the left, past a certain threshold, would trigger the rightmost default action, and it would occlude its partner sibling actions. And if you were to release past this point, that would trigger the action. So we're going to have to deal with all of this information. And so we can do it in multiple steps, but maybe first we can start with just swiping, adding some kind of drag gesture and making sure that we can move and offset the original text, and then display incrementally these swipe actions and get that all to look good. And then we can worry about other concerns like animation and getting it to stick open and getting the default action to trigger later on. And then, of course, dealing with velocity after that. We can layer on the concerns one at a time. All right, so let's begin with a blank slate. I have this swipe actions view, and it has some text inside of it. And as we said, we're going to want to begin by getting this thing to swipe. So we're going to need a few components. Firstly, let's start with a drag gesture. And I'm going to make a computed property here called SomeGesture. Going to construct a drag gesture and have 2 callbacks onChanged, taken this value, and then also an onEnded. And so these callbacks are going to get triggered when the user actually is dragging, but we're going to want to update some piece of state that we can use. So I'm going to set offset. Here I'm going to make this a CG float, start that out at 0, and then we'll just change that in onChange to be the translations X property, the width of the translation. And then on ended, we can, I guess, reset it to 0. So it'll just snap back when the user finishes dragging. So we'll throw a gesture on here, put our drag gesture in here, and then muck around with the preview. So, of course, nothing's going to happen because we're not using our offset. So I will throw an offset of X in here equal to our offset. And trying again, yes, we can drag it and it will snap back in a rather sudden and jarring manner when we release our finger, or in this case, the cursor. If we wanted this to look slightly less awful, I could throw a with animation wrapper around here. And now it will jump back in a little less of a jarring manner, which is great. Okay, drag gestures are pretty easy, so the next step would be to incrementally disclose our swipe actions. Of course, we don't have these at all, but we want to get those in there. Some placeholder swipe actions that will reveal themselves, stretch into place as we extend this view, offset it to the left. So there are a few ways we could do this, but let's keep in mind that we want them to sort of appear in from the right like this. So it's important that whatever view we attach them to extends the entire width like this. And I'm not sure if this text does at the moment. We can check this out just by putting a background on it, a really ugly red background. So yeah, that's not going to cut it. We also might not want to offset those views as we add them. So we want to make sure that whatever we add is not under the thrall of this offset that we've added here. So maybe what we can do is add a frame modifier and make this thing go all the way from edge to edge. So that's nice. And whether or not we want it to be stuck to the leading edge, maybe we can do that right now. Throw it in an alignment, leading. So that's nice. And we can then even pad this if we feel that looks better. And so now over this view that we have the background on, which we'll eventually get rid of, we can have an overlay and align this to the trailing edge. And here I can just have, let's say, the color blue fills the whole thing. That's not exactly what we want, but we'll worry about that in a moment. We'll have another overlay where we can have an image, system name, and I'll go with sparkles. And now on this I can throw a width, and let's do 30 or 60. And that kind of looks like what we want. Of course, it's expanded, so we don't want to start it off as expanded. And also when it is fully shut, we don't want it to appear at all. So we can say clipped onto this. But now if we were to expand this, it would appear. And we can even have this be tied to the offset. Now, of course, the offset is negative when we drag to the left, so that's not going to show up. It'll show up when we push to the right. So we can do a negative offset. And now it appears. It's not so horrible. Now we can also get rid of that unsightly red background, and we can pull this thing in. So that looks kind of okay, but we have a much further to go. A couple problems right off the bat. First of all, because there is no background here, if I'm dragging here, which I'm trying to do, it doesn't work. It only works if I click on the text. If you've ever run into that problem with SwiftUI, and you want a clickable area that's not clickable, well, what you can do is you can say content shape and then just throw in a rectangle. I actually think I want this outside of the frame, and now it's draggable from out here in the void. That feels better. Now this only happens to look okay because we only have a single swipe action. So let's quickly duplicate our efforts and make a second swipe action. Let's make it red with a trash can icon and put this in here. And well, now our trash can is there, but it's hidden. If I flip these around, we will see our trash can on top now. So we want to share this space, as we looked at before in our little diagram, between the trash can and the sparkles. So we need to do a little bit of math. Very, 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 very basic math. Basically just division. So we have some total offset. Let's say 60 pixels, and remember it's negative. And then we want to calculate the trash width as well as the sparkles width. And really, we could think of them each being 30. That's kind of what I looked at before. But another way to do this is actually to have the trash can, which is behind the sparkles, take up the entire width and have sparkles appear on top of the trash can, but only take up half the size. So they're sort of overlapping. That might sound a little confusing. Let's actually look at what we want for this. So I'm going to give ourselves some more room. I'm going to start out by making a Z stack. I'm going to align these on the trailing edge. That'll make it easier to work with. And I will give the first element here the full width. But then let's just start in by hard coding this, and I'll just say offset divided by 2. And there we go. They each have half of the space. Now the icons are all wonky, but it is allocating the right amount of room. The trash can looks awful. The sparkles actually look sort of okay. One way to fix this would be to take the overlaid icon here and once again add some alignment to the leading edge this time. I'll do that for both of them. And now, well, they're on the right side. They still look fairly awful. But that's solvable. I'll just have some padding on the leading edge to each image. And now it actually doesn't look so bad. Not too shabby. And ideally, we can have them sort of open to around there, where there's a nice looking even amount of space on either side. We'll refine this as we go on, but this works for now. Obviously, we want these calculations to work even if we have 3 actions or 4 actions or just 1 action. So we're going to have to genericize this later on. So let's clean up some of this noise. Now, the next step, I suppose, would be to make sure that this snaps open instead of just continuously shutting. And that actually won't be so difficult to do. Here, when we end our gesture, that's when we snap it back. So basically what we could do is figure out where did we end, and if we're at a particular location, we can decide to, instead of snapping shut, snap to our expanded state. And right now we'll also just sort of mess with some values until we find something that looks okay around there, possibly. In order to know what's going on, maybe we can even have some kind of overlay that is just the offset, and shove this down at the bottom. Okay, so maybe if we get past, let's say, -70, we can jump to something that looks good, which is, I don't know, around -100. So if, let's get the value, if value.translation.width is less than -60, then we're going to want to set the offset to -100, otherwise to 0. And that's pretty straightforward. So now we jump to -100. And that's great. It works nicely the first time. The only thing is, once I start again, it sort of snaps back to the beginning. So once I start to drag, it jumps back to 0 and then -19. But it works, you know, if we get it past 60, it expands. If we get it really far, it goes back to -100. And if we have it less than -60, or I guess greater than -60, it will jump to 0. So yeah, we're getting there step by step. But that next problem is, once it's expanded and you start to drag again, it's really awkward, that jump back to 0. So how do we solve this next problem? And that's what this video is going to be, a series of solutions that introduce new problems until we get to the end. And this issue is introduced up here, where when we start to drag, we set the offset, which is used to, well, offset everything, to the current drag width, which starts out at 0. It's the translation for that new drag. It forgets about where the offset used to be. And this is for the entire drag. So when we start this out, it's going to be 0. And then if we move our finger, 10 pixels to the left, it's going to be -10. And then if we move it a little bit more, it's going to be -15. So this is the translation for the entire drag, not just sort of since it was last triggered. So we don't want to do something like plus equals the translation. It will sort of, we could see what happens. It's going to get insane. Every time we move it, it just adds to the previous offset. So that's definitely not the answer. So we can think about what we want to happen. Well, when we're at -100 and we click and drag a bit to the left, well, we want to take this translation and add it to where we started. But the problem is, where we started is going to be in this value that we're overriding. So we sort of want to store off another piece of state, which I'll just call start offset. And at the beginning here, we can set start offset equal to offset. And then instead of simply setting offset equal to the translation, we can take that and add it to whatever we started at. So if we started at -100 and we move -15, well, the offset, we want to be -115, so that sort of makes sense. But if I try this, we have that same problem as when we did plus equals, and that's because we're setting start offset to the previous offset. This is kind of just an awkward way of doing basically just plus equals. So that's not great. We only want to store the start offset if it's the beginning of a new drag, which is not something we get automatically here. This is going to be called every time it changed. There isn't an onStarted method that we can chain onto our drag gesture. So we're going to also have to store this ourselves. So I will say is dragging equals false. And then if we're not dragging, we can set the start offset, and we can say is dragging equals true. And it's always safe to set is dragging equal to false in the onEnded clause. So let's see what we have now. Drag to -100, and now as we drag, it works. So that's pretty great. Another demon has been slain, and we can keep going. And before we continue, one brief aside. I've added some code here secretly, which I don't usually do, but this is a bit of stuff that we're going to delete immediately, which is predicted end translation, this other value on the drag value. And let's visualize this. So I'm just basically setting that to this variable, adding the start offset to it, and we can see this red line appear. And if I move very slowly, it sort of tracks the actual offset. But if I move more quickly, we can see that it's jumping around a bit as I accelerate. It's basically, if I were to let go at a certain point, which I just did, it's where, if you took the velocity of the drag, where it thinks that the offset would end, where the drag would end. And it's one of the built-in values, properties on the drag value that involves velocity, and we can use. We can't use it, unfortunately, to adjust the animation as it stands, but it is useful in one regard, which is right now we said that that magic number was -60, which is where the view would jump. But what if one sort of throws the thing? Well, it's not opening, even though I'm giving it some force. We can see that the predicted end translation would have been beyond that boundary, but we literally have to make sure we drag past that. And that's not so fun. If we are dragging with some speed, we can see that we can get up to well past the boundary, and that just ends up feeling better. So instead of checking the translation, we're just going to check the predicted end translation and make sure that's less than -60, in which case it'll open even if I just throw it. So it feels a lot better. I just kind of throw it in that direction, and if I throw it backwards, it'll still close. So that feels much better. Okay, I'm going to delete this code now, and we'll continue with our slightly better boundary checking logic here, taking into account the velocity of the drag. The next reasonable step along this path would be to, now that we've gotten it shutting and closing, would be to getting that default action to trigger, or to attempt to trigger, once we've passed yet another threshold. So we determined that -60 was the point that this thing would open. And now there's going to be some other position, let's say at -250 or something, or where once we pass that, we want the blue, whatever the rightmost action, to fill the action pane. So to occlude all other actions and stretch to fill the entire offset, and potentially even add additional offset. That's what I've done in the example I showed at the beginning. And this one's going to be a little trickier than what we have already. So in order to determine the end position here, we're doing that onEnded, but this is something that actually is going to be done as we're dragging. So if we ever cross that threshold, we want the blue bar to shoot ahead, and if we drag back, we want it to recede. And it's only if we release the blue bar whilst past that threshold that we want the action to trigger, whatever that default action is to trigger. So let's get to work. So perhaps we could start with extracting some of these magic numbers. So there is the expansion threshold, which we set to -60, and we made that let's just make that a CG float because everything else is. So if this goes beyond the expansion threshold, and then I suppose we have this other magic number, expansion offset. We'll set that to expansion offset. Oh, and we have to say it's a CG float so it doesn't get angry at us. And then we can also have ourselves a trigger threshold, which we could make negative 250. And so then while we're dragging, if the current drag amount, which is actually going to be including the offset, so if the offset is less than the trigger threshold, we want to do something. For now, we can just have another piece of state. Let's say is triggered and set that to false. And actually we can make all of these lets just to signify that they're constants. That should not change. And we can just say is triggered equals this for now. And then visualize it somehow. So maybe scrolling down here, we can have a background just for now of pink. And the opacity will be determined by whether or not we're triggered. So if we surpass that threshold at negative 250, the thing turns pink and we're triggered. Of course, if we release, it's staying triggered. So that's not quite what we want. So we'll have to remember to, when the user is done dragging, to set that to false as well. And there it will be reset. But of course, we don't want to have this ugly background, but what we instead want is for blue to fill its allotted space. And what is determining blue's space right now? Well, it's this bit down here. And I could say default width. So if we're triggered, we want to basically take up the whole negative offset. Otherwise, we can say negative offset divided by 2 for now. And this is the default actions width. And let's see what this does. Aha! And so it jumps ahead. Now that we have that, we can remove our pink background. So it's jumping, but we would like it to instead gracefully animate. And we can try some things here. I can say animation, spring, and then we can trigger this only on a value change. So whenever is triggered, it changes. Perhaps then we can animate with that spring. And unfortunately, that doesn't quite work. And that's probably for reasons. Working with these animation methods and trying to trigger them under particular circumstances is always a little difficult. It's always going to be finicky, which is why we're eventually going to move away from that when we want velocity in our animations and other things. But for now, what we can do is we can wrap this in a with animation block. Of course, this will make the entire thing animated, which is weird and feels sort of like we're dragging this thing through molasses. But it will animate. Open, so that's all right, I suppose. But what we can do is instead of just using the default, which I believe is spring, we can instead say interactive spring, which is built particularly for these types of interactive animations. So there is actually a slight spring, but it's almost indiscernible. And it feels good, I suppose. It's actually not so bad. There's a reason why it exists as interactive spring. It's probably a default for many interactive components. I'm not sure if it is for their built-in swipe actions. It's kind of hard to tell, to be honest. But now that we have it, there's just enough for it to spring open. And I'm not sure if it's really following the spring value that we put here, but we can test it out. So take a note of this easing. And then if I remove and try again, we'll see, oh yeah, that it was totally doing something. Interactive spring does not feel good. It's too fast. So we can go back to using the spring. And now, of course, if we have triggered and released, we don't want it to revert to this expanded mode. We want it to hide away completely. So on ended, we can move this down here, resetting the trigger to the bottom, and check to see, well, if the translation is beyond the expansion threshold, but also we are not triggered. And if that's the case, then we should shut. So if we don't trigger, well, we're past the expansion threshold, but not triggered, so we will open. And then if we go beyond that, it will close. All right, so that looks pretty good, and I'm pretty satisfied overall with how this basic version is coming along. The huge problem is that there is no inertia, which you can't really maybe feel when watching the video, but if I go slow, it opens. If I go fast, it opens basically the same speed, no matter how fast I move my mouse. And that is just enough to drive someone insane. It feels really bad on the phone. It feels like just something is off when you're actually touching it. So we'll get into that shortly. But first, it would be great if, we could actually trigger some kind of actions. These are not buttons right now, and that doesn't really do anything. Also, we've hard-coded how many actions there are, which feels a little too hacky. Like, ideally, you can come away from this first part, and if you're okay with the lack of velocity, the lack of inertia, you can still implement something in your own application. But you can't really do that yet if, you're going to hard-code these values in here. It's not very flexible. So let's work on that next. So let's just first mess around manually. Let's see, okay, what do we have so far? We have just 2. So if I copy this one more time, make it a yellow color here, and let's use a folder. Let's see what's going to happen now. Well, oh, the trash is gone because, yes, this yellow folder is taking up the offset. So now we have to think, how do we break this offset apart for everyone? Well, it turned out that when we just had 2, it was pretty easy because we could either give something the full offset, the leftmost item would get the full width, and it would peek out beyond the other 2, or beyond the other 1, and we can give the other one, the rightmost one, half of the width. But now that we have 3, we have to give the rightmost one 1/3 of the width, and we have to give the middle one 2/3 of the width. So we can say, times 2 divided by 3. And now they each get their own allocation of the width. The only problem is now it's too small. So we have some magic numbers for what the expansion width is, and it just doesn't really work with 3. So we're going to want to pull out these magic numbers and basically pull out these actions, accept these actions as inputs, and then calculate some of the offsets based on the number of actions. So let's first think of what we want for an action. We have this color, we have an icon, probably want a name eventually, and then we'll want an action that will trigger when you actually click on these. These should be buttons, so we'll encode all of that and wrap it all up in a struct. So down here I'm going to say action, and I'm going to have a color, going to have a name, we're going to have a system icon, which is going to be a name of that icon, and then we're going to have an action as well. And then up here, when we create our swipe actions view, we're going to accept some actions. So we'll take a list of actions when we create this thing. And then down here in our preview, we'll have to provide them, which we can do. So let's say actions, and I'll make a new action, color red, delete, trash.fill, and for all of these actions, I'll just print I am deleting. Make another one, yellow, folder, or I guess I should call this move. That's probably what the folder represents. I am moving. And then we'll have our last one, which was blue, magic, sparkles. I am doing magic. Okay, so now we have some actions. We're not using them yet, but we've created them. So now we'll go up here, and we basically want to replace all of these with iterating over our actions and then having a special view for the action. But maybe, just as we made our action, it would be nice to have an action view. Struct action button, I suppose. And this can accept one of our actions. I'll make it a let. We'll have a body here. And for now, we'll copy this and then adjust things. And so instead of using this blue color, we'll use our actions color as the base color. We will use the actions name here, but actually what we could do is replace this with a label. So the title key could be the name and the system icon. And we could still have padding. We might want the label style of icon only, but having this label here will be nice for accessibility purposes, so that screen readers will read out this button and know what it's supposed to do. For the width, well, we can accept that as an argument. This should be a CG float. We can also pass in more information, and every action button could calculate its own width. It's really up to you. And we won't worry about this animation right now. So now that we have this, we can move up here and say for each. And then we want to go through our actions, but we also want to know their index so that we can do some of this width math. So a way to do this is to wrap these actions in an array that is enumerated. You can't just have it be enumerated because that is not a random access collection, which you need to pass into for each. So this is a bit of a shuffle we must perform. And then we need to identify these elements, which are actually tuples here. So I can say ID is the offset, and then I'm going to get in both the offset and the element. And the element is actually the action. So now I can take my action view and throw in the action. And for now, let's say the width is going to be negative offset, just so we can start seeing what's going on. I will comment out the rest of this. Oops. And of course, this is the index, not the offset. I'm getting my terms mixed up. And if we preview this, let's see if we get anything that looks like anything. And yeah, it's just one button. So that makes sense because it's the topmost button and it is taking up the whole width. So really what we want is we want to give every element some portion of the total offset. So the first element will get 3/3 of the offset, 2/3, and then 1/3, respectively. We didn't say 3/3 because that's one up here, but you know, it's nice to think, how can we normalize these mathematical expressions so that it doesn't seem arbitrary? So we can come up with something here. So I can say let width equals negative offset times basically the proportion, which will be something over, well, why 3? Well, it's because there were 3 actions. So the actions count, which also needs to be a CG float. At this point, we're going to have to coerce some things. And then how do we figure out these numbers? So for the first one, it should be 3, but we know that its index is 0. So if the index is 0, we want it to be 3. If the index is 1, we want it to be 2. And if the index is 2, we want it to be 1. How can we write some kind of expression that will get us these answers? Well, if the index is 0 and we want 3, well, 3 minus the index should do it. And I can wrap this up in a CG float as well. So if our index is 2, we'll say 3 minus 2, and that'll get us 1, etc. So that should get us the right proportion of everything. Let's see what we have. And then, of course, we have to use the width here. So let's see what we have now. And there we go. Yes, it works. The only problem is that the expansion looks awful. So I can delete this stuff for now. I'll keep this as a reminder here for a moment. So how do we make the expanded state wider? Well, it has to depend on the number of items. And basically, we want to find the ideal width of every item, which seems to be about 50. And multiply that by the item count. So 50 times whatever that actions count is should be our expansion offset. So instead of having this pre-calculated, it can basically be CG float. We can wrap the actions count times 50. And so, oh, and of course it has to be negative as well. So there we go. It looks good. And just to quickly ensure that this is the case, if I get rid of move, comment that out, it should still look good. Ah, so something's happening there. I must have miscalculated a thing. All right, and the culprit here, I've found that the reason why they kept getting that full width was because, of course, here I hard-coded something, so it should be another actions.count. And maybe I can even pull this out to be the proportion. And now it looks better. With just 1, it gets the offset of negative 50. And now if I add a second action, it looks good, and I can keep doing this with more actions. And now that my actions have actions in and of themselves, I can turn this into a button. So I'll wrap this in a button constructor with a label. And as the action, I will call the actions action. I will also make this into, it's going to look awful if we take a look there. Oh God, it made everything blue. I'll say button style plain to remove that unsightly coloring. Cool, and then I can click on these buttons, and if we open up the debugger, it's doing magic. It's moving. It's deleting. What it is not doing, of course, is closing this thing. So the action button, of course, doesn't know that it's embedded in this action view, so we will need to pass that information along, make it say dismiss. It can be a function like this, and we can also dismiss after that. Swipe up here. For dismiss, we can basically set our offset equal to 0. but it does not animate, so I can say with animation will make the offset 0. And now it will both do the thing, let me clear the logs, it will move or delete or magic and also close. So that's nice. I can pull these onto separate lines to make it slightly less awful. And then of course there is the problem of the triggering here. It's no longer triggering because we've given the width to just be this calculation. So we never know if we are the default action and should we get the full width. So I can say is default, and it is the default if basically the index is equal to actions.count -1 if it's the rightmost item. And then we would also need to take into account whether or not the thing is triggered. So if it is default and it is triggered, then we get the whole negative offset. Otherwise, we do this calculation as we had before. Let's see if this works. It does work. It's too fast, of course. So we can take our previous little helper saying animation spring if the value is triggered. And then hopefully this looks better. And it does. So that's nice. Now, something else you might notice, which you will not see in this video, unless you have a very complicated, I don't know, haptic YouTube setup, is usually if you drag beyond this threshold or back, you will feel a little haptic feedback. And one easy way of getting this here would be to say on change of is triggered, whenever this changes one way or the other, we can say UI impact feedback generator, and the style can be, I believe medium feels like what they use in the default one, and then just impact occurred. And now, well, you should feel something if you do this on your app, I promise. Now the only thing is, dragging this all the way does not perform magic. That's kind of the whole idea. If you release when it's expanded like this and triggering, it will do the default action, perform it. So we can, now with that out of the way, delete that, scroll up. So if we are triggered, then we can get our actions last, and if there is an action, have both of these together. So if there's an action and we are triggered, then we can perform our action. And let's see if this indeed works. Aha! It's working. Okay, great. So now it's kind of like the built-in thing, sort of. Except you don't have to use it in a list. Now, as I promised earlier, every time we solve a problem, we introduce another problem, and one that I was kind of evading, clicking around, is if we try to drag on these buttons, it first triggers them as buttons, which is not what we want. We want the sort of the button action to trigger only if we're not swiping. So we need to sort of reprioritize our gestures, and luckily, it's not too difficult to do that. We just need to change this from a gesture to a high priority gesture. And by doing this, it will take priority, hey, over the button pressing. You could even begin to press and then swipe and it'll cancel the button press. But if you just press, it'll still trigger those actions. So that's pretty great. And with that last nuance, we've pretty much completed the basic version of our app. We could just remove this overlay here, and then it looks pretty decent. The one last thing to do would be to become parameterized by this view itself instead of just taking this view here that we've kind of preordained. We could accept any view, and that's actually pretty easy to do as well. We just need to parameterize our struct here with a generic content type. You can name it anything you want. Generally, it's something like content, which has to be a view itself. And then we can stash this somewhere. I can say our content is going to be content. And then to make this really easy to use, we're going to have to make a custom initializer. What we're going to do is something like this. First of all, we needed actions. And so we kind of were using the free initializer because this is the only abstract member. So Swift automatically synthesized our initializer, which we used at the bottom here, which took just the actions. But now we want to make things a little more complicated. We need a list of actions. But we also want to take in our content, which is going to be a view builder. So you have to add this annotation before the keyword. And it's going to be a function, a thunk, that returns content. And then inside of here, we're going to set self.actions equal to actions and self.content equal to the result of calling that view builder function. And now, of course, down here, this will break because we need to pass in our trailing closure. And here I can steal what we had before, cut this out, replace it with the word content, which is now our little generic parameter. And I can throw the content in here and prove that it is indeed using this by changing the foreground style to blue or something. So, hooray! We can now pass in our own text for this little swipeable view. So now I'd say this is a good place to pause before we deal with even additional complicated issues and sort of further venture out into the realm of diminishing returns, where I love to spend so much of my time to try to make this more satisfying to use, because on the phone it is truly just not right to not have the inertia. iOS is so good at taking into account animation and those little subtle details, which really makes it fun. I mean, that's why I'm probably recording all these videos and spending all this time, is because it, it tickled some deep part of my brainstem. And I like those subtle animations, the subtle details. They really make things feel satisfying, and they will eat as much of your time that you're willing to feed it. But let's pause here with a functioning view. I will post this file onto the internet, into a GitHub somewhere. So if you want to play around with it, you may. Let me know if you can find any issues with it. And so yeah, thanks for watching, and don't forget to like and subscribe. I integrated it into the thing we're doing. Okay, see you in the next part.